You're supposed to simplify this, right? Is it this one?
Yeah.
Kids, it'd be nice if you could respond to me in some form.
Yes.
Yes, thank you. That'd be great. They're all the same case. So we need to simplify that. There's different orders you can take. How can someone tell me what they did first? What did they do first? Okay.
Fix the k to -1.
Yeah, so what do you mean fix it? Yeah, so you could rewrite it if you want to. Make it k to the first times k to the 1/3 over k to the 2/3. Okay, what's next? What's next?
Couldn't you just
Yeah, do what?
add k to the 1/3 over k to the 2/3?
No, you can't. On top, you're multiplying them together. So what do you do with powers of powers? You add them. So that's going to be k to the first plus 1/3 over k to the 2/3. So it's going to be, hold on, but it's supposed to be k to the 4/3 over k to the 2/3. Now, when they're dividing, what do you do? What do you do with the powers? You subtract, exactly. It's doing that fun thing again. What does it turn into? Yeah, it's k to the 4/3 minus 2/3, which is k to the... There's different orders you can do it in, but that's the correct answer. You could, at the beginning, add them together. I mean, how could you also do this? You could combine the denominators right here if you wanted to. If you did that, you end up with k to the 1/3. What would the power be on the bottom? K to the what? What's 2/3 minus 1? 2/3 minus 1. Negative 1/3. And what do you do with powers here? It would be k to the 1/3 minus negative 1/3. What's 1/3 minus negative 1/3? So it's another path to the same answer. Another path. A great first step on this one would be, what would be a good first step? Yeah, into the power. So you end up with the top stays the same. Actually write it out. And again, yes, I know it's m and n, which is annoying. So it's going to be m to the what power? M to the what power? You're multiplying the exponents. M to the 1, correct. N to the 1/2. You distribute the 1/2. You multiply. So the 1/2 times 2 is what? 1. And then 1/2 times 1 is 1/2. So now what do you do with powers now? Hint, don't add them.
You subtract.
Yeah, so it's going to be m to the 3/4 minus what, Mar? 1, and n to the 1/4 minus what? 1/2.
It's a negative 1/4.
Negative, oh, it's negative 1/4, thank you. That's important, isn't it? Negative 1/4, exactly. So what do you end up with? A power for m? M to the what? M, negative 1/4, and n to the negative what? What's negative 1/4 minus 1/2? What's negative 1/4 minus 1/2? Negative 3/4. So technically you'd be done, but usually you don't like having what in your final answer? Yeah, you usually don't like having negative exponents, so you would write 1 over m to the times n to the, yes. That would be a better answer, right? 47, right with radicals. So this is, what form is this called? This is called what form? This would be in exponential form. And you're converting it to what form? Radical form, right? Radical form. So basically they're asking you, what does 2/3 power mean? Can someone raise their hand and tell me? It's blah, 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 blah to the 2/3. What does that mean, Liv? Yeah. 2y plus x squared, exactly. Good job. It's the cube root of 2y plus x squared. That's what they want you to write. That's what it means. It's the cube root. Whatever's bottom is the root, and whatever's up top is the power.
So that's always the case. The only one that's on the bottom is squared.
Yeah, and the thing is, there's another way to rewrite this, right? There's actually a second way you could write it. What's the second way you could write it? 2y plus x to the what power? To the 1/3 squared, right? This is not radical form though, right? This is not radical form, but can you use it? What this shows you is, does it matter what order these are in right here? Can you switch those, right? Because 2 times 1/3 is the same thing as 1/3 times 2. So you could, this is fine, just keep in mind everybody, you could stop right here, but I want to show you what the other form is. The other form is, you could write this as 2y plus x to the what power? Squared all to the, you can alternate it, right? So what do we have right here? This is the cube root of 2y plus x all raised to the what power? Like to the second power, right? Technically, it's the same thing. Generally speaking, I like this one a little better right here. But it doesn't really matter. Yes?
So that's it. That's simplified right there.
It's not simplified. This question does not ask you to simplify. This question asks you to write with radicals. This one is simplify. says simplify each expression. Positive exponents only at the end. So what do you want to do first? Tell me what you distribute the what to where. And you can do that because it's all multiplication. Hallelujah, hark the herald. There we go. So we end up with p to the what power? 1/2 power. Oh, that's close enough. Yeah, 1/2 over q to the 3rd. Thank you. Over what? 3 to the what? 3 to the 2nd power. P to the what power? 4th power. Thank you. And q to the what? 4/3. Take. You could, but again, so you could write it as, yes, 1 over 9 times p to the 1/2 minus what?
I don't think that way.
4 minus 4.
Yeah, p to the 3 minus what?
Q.
Sorry, q. Thank you. Q to the what? And this eraser thing is going to really annoy me. Q to the 3 minus what? 4/3. What is 1/2? What is 1/2 minus 4? -7/2. Thank you, Zoya. So it's p to the -7/2. Q. And what is 3 minus 4/3?
5/3.
Thank you, 5/3. This is almost done, but what is in there that we did not want to have in there? Bring it to the bottom, right. So what do you end up with?
Wait, is that a -7/2 or a -7?
That's a -7/2.
Okay, right.
So it's q to the what power? 5/3 all over what? 9. That's close. I gotta write my 9s like 9s and not q's, right? 9 times what? P to the? So I could ask you, Aubrey, like you asked before, is this exponential or radical form? Aubrey, you have many voices. Exponential. I could ask you to put it into radical form. Well, look, just do each part. You know how to do it. What's q to the 5/3 mean? The cube root of q to the 5th over 9 times what? The square root of. Yes, and you don't. Do you have to write that 2 in there? Technically speaking, do you need that? No. It's kind of nice. Just be careful. Just when you write that, you see how it says 9 times the square root of p to the 7th? It looks like 9 squared. If you write it like this, I would love it if you did this. Parentheses. That's awesome. I love it when people put parentheses around radicals. So therefore, the root sign, doesn't get stuck as an exponent to something else. I can. Got it? Put everything away except a pencil. No, I'll be right back. Actually, get the folders.
Who has the soul, man? Let's talk to some people.
I do.
Ball game.
That's not an eraser, though.
I never made birthday.
Of course.
Quiz, nah.
What?
Quiz, here it is. Just a quick interview. No, it goes like this. What do you think about the second? 8.2. All right. Can I please borrow a pencil? I'm sorry.
Yeah, I know.
How do you guys get up in the morning? Do you have a big sign on your wall that says like pants first, then shoes? And do you need to like that?
What? I don't even know what.
I will explain it to you if you need to. Bringing a pencil to class is as basic as remembering that you should probably put your pants on before your shoes.
I know. It's just that I never used this in my classes. Sorry.
I understand. What month is it?
February.
February. It's like the 50th day you've been in my class.
It's probably
you use a pencil like every single day in my class.
probably so.
Go.
Alright, let's go.
It is the 4th today. De nada.
I actually forgot to give you. Okay.
It's the payoff. I get to make fun of you a little bit, and you get a pencil. Get this weird Pavlovian programming. Oh, and Harry's not here. When you're done, flip it over. Draw me a picture of a pony. Actually, wildcat. Draw me a picture of a wildcat. Oh, that was it. Oh, I thought that was the other class. Pony. No. How about a picture of your mood? How about that? Hey guys, it's a minute. Okay guys, Hannah, start collecting it. Let's go. Let's go, kids.
Can you go over the first one?
Possibly. Yeah, okay. Do I have all the quizzes? Do I have them all?
Yes, I believe you.
Good. I believe I can fly. Okay, kids, here we go. So you want to ask about that one? We do have a minute or so. I can show you that. So on the question, it asks you for. Let's see. It asks you for. Wow, I think the recording's been going for a while. Huh. Okay, so what does that negative exponent mean?
Means that
You've done this 100 times. Don't overthink it. What does the negative mean? 1 over 16 over 81 to the what power? 3/4. That's all the negative means. We just did that several times. Just did that. Now, what does 3/4 power mean?
The 16 over 81 to third.
Yeah. Now, do you want to should you do the roots first or should you multiply first? Roots first. So it's the 4th root of this to the what power? What's the 4th root of 16? 2. What's the 4th root of 81? 3. Okay. What's 2 cubed? What's 2 cubed?
8.
What's 3 cubed? So what is the final answer? No. 27 over 8. You flip it over because it's 1 divided by it. Next thing we need to talk about is when you have radicals that aren't quite set up the way you had before. So for example, let's say you had the square root of 72, and I asked you to simplify that. If I asked you to simplify the square root of 72, is that going to simplify to an integer? What do you think? No. You know that because what's 8 squared? 64. What's 9 squared? So what can you tell me about the square root of 72? It's going to be between 8 and 9, right? And I've already kind of told you anything doesn't simplify nicely to an integer, it's definitely going to be irrational. It's not going to be like 8.5, right? It's definitely irrational. When you look at 72, let's just think about what we know about 72. If I asked you to factor 72, what can you pull out first?
8 and 9.
You could. Or what's smaller that you could pull out first? You could pull out 2 first. If you pulled out 2, what's left? 36. So you could write it as the square root of 2 times 36. Because what is 2 times 36? So here's the first simplifying radical expressions rule that you have. If you have the square root of 2 things to multiply together, you can write it as the square root of 2 times the square root of 36. This right here is your first. This is valid. You are allowed to do this. Absolutely. But what is the square root of 36?
6.
So this simplifies to 6 square roots of 2. This would be the most simplified form of the square root of 72. So when we were looking at 72, we were able to simplify this with what did we find inside of it? What is 36? Not just a square. Anything's technically a square. It's a perfect square because it's an integer squared. So what are you going to do in this section? You're essentially on a hunt for squares. Sometimes it might not be as clear, I know that's a bad word to use, as 36. So what do you do? Instead, let's say you did 8 and 9 instead, right? Mar said, okay, what happens if we went to 8 and 9 instead? So it's 72 and we went to 8 and 9. Well, what can you do with 8 and 9? What's 9?
2 cubed.
What is 9? 3 and 3. What is 8?
2 times 2 times 2.
2 times 4. And what is 4? 2 times 2. So what do you end up with?
2 cubed.
You end up with this right here, right? So what do you see? How many squares do you see?
1.
I see 2 squared and 3 squared, right?
When do you want to do 2 cubed?
When did you 8 times?
Kids,
Yeah.
just chill with me for 1 second here. What's 2 times 2?
4.
What's 3 times 3?
9.
What's 9 times 4? 36.
Times 2.
I understand that. That's not what I'm asking you for. My point is, when you do this, can you go any further right here?
No.
So when you do this, you're looking for pairs. You see a pair of that and a pair like that, right? These 4 numbers will make the biggest square. What's the really easy way to figure out what the square root of these things are? 3 times 2. You just take one number from each pair. You take one number from each pair. So it's going to be 6 square roots of 2. So here's the thing. If you get a huge number, can you make these factor trees pretty easily?
Yeah.
You pull out the smallest number, pull out a small number. You go all the way down, and then what do you look for? Pairs. And that very easily clearly shows you, and again, the word I don't like using, clearly shows you what is the biggest square root in there. Simplify that as far as you think it can go. What do you think it simplifies to, Aubrey?
I got 6 and radical chain equal and then 3.
6 radical 3? Who got that? Yeah, that's correct. Good job. Because what is 36 times 3? It's 108. You factored it, right? You found 36. It is 6 root 3. Can you go any further than that? No. So if you were to do this out like the tree I showed you, what can you pull out first? 2 and, or 3, yeah, but 2 and 54.
Yeah.
And then you could pull out what?
2 and
I like pulling out the smallest things first. 2 and 27. And then what? 3 and 9. I like pulling out the small and 3 and 3, right? So 3 and 3. So what do you have here? You have a pair and you have a pair. So it's 6 root 3. 3 times 2, root 3. Only thing that changed was the...
Wait, I don't...
Okay, so I'll show you again. So we now know what this tells us is that the square root of 108 is the square root of 2 times 2 times 3 times 3 times 3, right?
Yeah.
Well, that's the same thing as the square root of 2 times 2 times the square root of 3 times 3 times the square root of 3. What is the square root of 2 times 2? 2. Square root of 3 times 3? And this stays the same, right? What's 2 times 3? 6.
So you multiply one part of each pair.
Correct, essentially. Do it. What is square root of 7?
1
Square root of 7 is not 1/2.
7 to the 1/2.
Thank you for the complete sentence. Yes. What is cube root of 7?
7 to the 1/2.
What do you do with the powers? You do not.
Add
You add them.
7 to the
1/2 plus 1/3. So?
So it's 3 6.
No, you do not.
3 6 plus 2 6 is 7 to the 5.
Yeah. 3 6 plus 2 6. So it's going to be 7 to the 5, 6. Done.